Nuclear fission is the splitting of atoms. It occurs when a large atom takes on a neutron and becomes unstable as its mass increases by 1. Keep in mind that the nucleus represented in this model is not an exact example and is only symbolic of this reaction occurring in other elements. To become stable, the atom splits in two and several neutrons may be ejected. Notice that the number of protons in the new elements must add up to the number of protons in the first atom, and the first atom's mass plus the initial proton is equivalent to the two new atoms' mass plus the number of neutrons expelled. An example of this would be uranium-236 splitting into krypton-91 and barium-142 and ejecting 3 neutrons. Each of these neutrons will collide with other large atoms, simultaneously splitting more atoms, which in turn will give off more neutrons. This continuous chain reaction releases large amounts of energy. We control this in nuclear power plants to produce usable energy, and we also can release this energy uncontrolled in the form of nuclear bombs. Nuclear fusion is the process of combining two smaller atoms to produce larger ones. As small atoms collide at high velocities, high amounts of energy is released and the two atoms combine. This can also throw off protons or neutrons represented here by purple beads. Notice that the mass of the initial atoms is equivalent to the mass of the product added to the number of particles given off. The sum of the protons in the initial atom is also equal to the product's protons. A real-life example of this process would be the fusion of hydrogen to make helium that occurs in our Sun. Our Sun begins fusion when two protium atoms collide at high speeds. A neutrino represented by V and a positron represented by white bead are given off. The explosion of a neutrino changes a proton into a neutron. This gives us deuterium. Collision with another protium atom creates helium-3 and produces gamma radiation shown by Y. Finally, another helium-3 atom created by this same process collides with the atom, expelling two protium atoms and leaving helium-4. This completes solar fusion of hydrogen-1 to helium-4.